Yeah. If I fail, my dad's gonna kill me. Are you busy?
No, what are you working on?
The Pythagorean Theorem. I just don't get it.
It's not really that difficult. Let me see your paper.
Good luck figuring it out.
Don't worry about me, I aced math. Alright, what do you need help with?
Everything. I probably slept through it all.
Alright, well, the point is that you're going to use the two given sides of this triangle here to find x. The Pythagorean theorem always works for right triangles. The equation to find the sides is a squared plus b squared equals c squared. See this side that's opposite the right angle? That's referred to as side C, the hypotenuse. The other two sides, or legs, are a and b. To solve the equation, we need to plug in the numbers for a and b. That gives you 6 squared plus b squared equals c squared. After that, we need to square 6 and 8, giving you 6 squared is 36, and b squared is 64. Add them together and you get 100 equals c squared. C is still squared. To get rid of that square, we need to square root both sides by putting them both under the radical sign. And that gets you 10 equals c.
So wait, does the answer always come out even in the end?
No, not always. Say, for example, a is 4 and b is 2. It's not going to come out whole. Just as we did with the previous equation, we have to plug in the numbers for a and b. We start off by using the equation for Pythagorean theorem, a squared plus b squared equals c squared. Then we plug in our numbers, 4 squared plus 2 squared equals c squared. After squaring both of the numbers, we get 16 plus 4 equals c squared. Then we add these two together, 2 equals c squared. And to find c, we square root both sides. And now the answer is going to come out to be an irrational number, somewhere like 4.47213 and so on.
So is that the final answer?
No, you need to round to the nearest tenth, which is 4.5.
Alright, so what do I need to do if I need to solve for a or b?
It's pretty much the same way. Say you need to solve for b. Just plug in the numbers for a and c, then solve. Watch. Alright, after you have the basic equation, we can plug in for a and c, which is 9 squared plus b squared equals 15 squared. And like you do with the other equations, you square the numbers that need to be squared, which is 81 plus b squared equals 225. Now you have to get b by itself, so you have to move this number to the other side. You do that by subtracting it from both sides. Over here it cancels out, and you get b squared equals 144. Now you square root both sides, which gets you b equals 12.
Is that all?
No, now we're going to do one that involves fractions. Just as before, plug in for a and b, which gets you 1/3 squared plus 3/4 squared equals c squared. Now I solve these two, I square them, which will get me 1/9 plus 9/16 equals c squared. Now to add these two fractions together, we have to find a common factor. The easiest way to do that is to multiply the two denominators together. Once we have that, we can solve the equation. Do 16 over 16 times this one, plus 9 over 16 times 9 over 9, c squared. That'll get me 16 over 144 plus 81 over 144. Now I can add them together. 16 plus 81 is 97 equals c squared. Now c is squared, so to find c, we have to square root both sides. The square root of 97 over 144. Well, you can't square root 97, so we leave that in the radical and put it over 12 because the square root of 144 is 12. And that's equal to c. Now you can simplify this further and make it a decimal, but it's a lot easier if you just leave it the way it is. So do you get it now?
Yeah, I think I do.
You're actually going to do your work, right?
No, probably not.
Then why did I just teach you that?
Because I don't like you and want to see how much of your time I could take up.
From the top, she's got a body like an hourglass, it's ticking like a clock. It's a matter of time before we all run out. When I thought he was mine, she caught him by the mouth. I waited a long while, she finally set him free. I told him I couldn't lie, he was the only one for me.
Is that all?
No. Now we're going to do a gay one.